A number of the recent purchases that I've got here in the solar shed require a 9-volt battery, a PP3 as I would call it, or as this one says, it's a 6F22, but I've also seen them referred as an MN1604 or a 6LR61. But whatever you call them, they're quite useful, and a number of products require them. But unfortunately we never seem to have many of these in the house, and I can't remember where this one came from. The Pound Shop or Wilko or something, and unfortunately as a result they don't last for a very long time. So recently I bought a rechargeable, and this is a nickel metal hard drive rechargeable, and I'm sure that will come in use, or at least it would, if I had a decent 9-volt nickel metal hard drive charger, which I forgot to get, so that's on the shopping list at some point soon. But while looking around eBay for a 9-volt battery, I came across this, and it's sold as an OkCell, and most of it is Chinese on the outside, but we can see this has USB written on it, 800 milliamp hours, well this one was 250, and 9-volt there. And if we look at the side, there's a power meter, and 3 bars suggest this is fully charged. Now, OkCell is a bit of an odd name, isn't it? Mainly you get things that are full of energy, power, and all that sort of thing, but this one's just OK. So a closer look at this battery here, claimed 800 milliamp hours. It's in a plastic case, and the USB connector is there at the bottom. So I think we can assume along this edge here, where the button is, the meter, LEDs and the USB connector, that there is a circuit board wedged at this side of this battery. But what will be inside? So inside the OkCell, I'm expecting to see a lithium cell. I'm expecting to see some sort of charging module. This is the TP356, which controls the charging of that lithium cell. It's also got a DW01 and a MOSFET package on here to cut off the output if that lithium cell gets too low, gets down to 3 volts, 2.9 volts, something like that. And then I'm expecting a boost converter, like I'm showing here, that will eventually create the 9 volts from 4.2, well 3.7 nominal. Well, I don't know about you, but I'm interested to look inside here, so I'm going to carefully split the label. Yeah, that's a bit off center, isn't it? So that the 2 parts will come apart, and I've managed to get my nail in there. This springs apart quite easily, or at least that side did. Oh yeah, there we go. Right, so inside we have, being a bit delicate here because obviously these batteries could pack a bit of a punch, I should say. 2 lithium cells here, lithium polymer I guess there will be, won't they? 3.7 volts, 420 milliamp hours, so 2 of those. And is this going to come out, or is it? Yeah, it's stuck in, and the batteries there connect at the bottom. It's marked B plus and B minus, so they are in parallel. So the main chip on here is marked HT46R002, and that is a microcontroller. So the HT46R002 is an 8-bit high-performance RISC architecture microcontroller device specifically designed for a wide range of applications, which is an interesting statement in itself. And as you can see down here, it can operate normally between 2.3 and 5.5 volts, so it's perfect to be powered from a lithium battery. And I believe this 5-pin chip here, which is marked PH01, well, I believe that's this TPS6104, a SOT23 package DC boost converter. And unfortunately I can't identify these other two chips here. One is marked 5353A and the other one B1PJ, both 5-pin. It wouldn't surprise me that this circuit needs a MOSFET to protect these cells, but I'm not sure either of these are MOSFETs. So hopefully I can get all this back in, because I'd like to continue using this. I think it's quite a clever idea. Of course, one of the issues you're going to get is that because this is a boost converter, you're likely to get some noise on the output that you wouldn't on a battery certainly, and here we've got 380 millivolts peak to peak. Whether you're happy with that on your battery or not, I guess, well, that's up to you. And how well does the OkCell cope under discharge? Well, I started off at 50 milliamps, raised it to 100, but the voltage dropped quite a bit at 100 milliamps, so I settled on 80 milliamps here, and it lasted for just over 4 hours, and the capacity total, well, 322 milliamp hours, a far cry from the 800 milliamp hours claimed on the label. But there's a really interesting point that this graph's showing here. The battery voltage maintained 9 volts just above and just below until eventually the circuitry kicked in and turned off the DC to DC converter. So if you place one of these OkCells inside something where you need to know that the battery is fading, you're not going to get a warning to tell you that that is happening. So for example, do not use this in a smoke detector, because you're not going to get the warning that the battery is about to pack up on you. And I also took a graph looking at the charging cycle as well, and 5 volts, you can see the current dropped away until it finished charging here, and it took 675 milliamp hours to charge this battery until it disconnected, and so again, that's a little bit away from 800 milliamp hours. And the final thing of note, if by accident you short this battery, it does in fact turn off entirely. There is some protection in there, and the only way to get it back up and running again is to plug a USB cable in, and then it will fire back to life. So all in all, I think this is an interesting device and an interesting direction for batteries. It's certainly, for me, much more convenient to charge, and it's got a reasonable capacity as well. In most cases that ripple on the output won't bother me, but I guess if you were putting this in something a bit more sensitive, that might cause a problem. So I have ordered another one of these and it's on the way. So do I think it's alright? Well, yeah, it's okay. Hopefully you've enjoyed this video. If you have, please give me a thumbs up, subscribe down below, comment if you can, and I'll see you next time. Thanks for watching.